Hello, and welcome to Spilling the Tea, the podcast where we explore the stories behind the technology shaping the future of privacy. I'm Lisa Loud from Secret Network, and I'll be your host today. This show is all about the real-world applications of confidential computing and AI, how they're being used to solve complex problems, protect data, and unlock new possibilities for individuals and enterprises alike. And we're not just talking about theory, we're sharing the journeys, the challenges, and the breakthroughs from the builders on the front lines. Today's guest is someone with a fascinating perspective. We have today Dylan Kawalec, who is a blockchain solutions architect and developer relations lead, specializing in zero-knowledge proofs and trusted execution environments. Currently at Phala Network, Dylan advocates for confidentiality on-chain, most recently launching a fully confidential TEE app on Phala's network. Welcome, Dylan. Would you like to say a few words?
Yeah, no, that was a great intro. Thank you so much. And hi, audience, and hi, Lisa, and thank you for inviting me. Yeah, I remember we had a really interesting conversation a few weeks ago about just our stories, and I learned that you were from Secret Network, and I was fascinated by just the world and how it's changing and into confidentiality. And so my background, as you said, I do specialize in zero knowledge. I've been researching a lot of things in TEE for quite some time. Also an ex-CTO and basically a protocol engineer as well. So I've done it all. And so I focus on security. I focus on, zero trust protocols. I focused on a lot of the confidential aspects of software and how to do network protocols, like in blockchain specifically. So that ranges from like working with Binance, Osmosis, even the Harmony protocol, and a list of other systems, and now with Phala. So yeah, I'm very excited about like Phala's direction and like kind of where we're going and the vision that these guys have, and I want to push that because we're working with other partners like Flashbots, and I believe in their mission, and I believe in what we're doing to decentralize or really to democratize trust. And that we have like this whole really interesting topography for hardware and how that works and what is a root of trust and this sort of
Yeah, I'm
thing.
excited to talk about DSTAC
Mhm.
today, and I'm excited that you've joined Phala and are working on this. This is what I'm really looking forward to the conversation today. And let's talk about DSTAC a little bit. Can you walk us through what DSTAC enables in terms of specifically remote attestations and how that fits into the broader landscape for verifiable decentralized computing?
Yeah, so verifiable decentralized computing is what's encapsulated into what's known as zero trust. So when people say zero trust, don't get scared. And I think a lot of people get a little worried when we say like that something is trustless and something is zero trust. So I wanted to spell that now
Yeah, it
because
sounds like something bad, doesn't it?
yeah, it does sound something bad, but like so did zero knowledge, right? Like it's like zero
Right.
knowledge. It's like over what? It's like it's private. Is it illegal? And so I think this was sort of the misconceptions way back then, and I want to do now the same thing here. So DSTAC is quoted as it's called the democratized stack. So everyone should be able to have their own framework to build a platform, and they should have all of the tools necessary to deploy applications that are confidential, that allow for ease of use through remote attestations and local attestations between different confidential hardwares. So there are many hardwares that offer confidential compute, and so we focus on like things like SEV, TDX, SGX, and so on. And so we want one framework that plugs into all of those, and so we can create these proofs of what the hardware and what the programs that are on that hardware are running. And so everyone
Right.
should be able to process in confidence, knowing that it's fast, it's confidential, it's verifiable, and zero trust, meaning so I don't have to necessarily believe that the hardware vendor is going to peer on my
Yeah.
data. I know
Ex-
that they will process that data, and that's really cool
You know,
because we're
that's
Mhm.
that's been one of the challenge with remote attestations I've noticed is that we have this idea that you can attest to the confidential computing, the back end, that you're doing something confidentially. But who is actually verifying that? Who's like putting a stamp on that? And is it a third party? In case if it is a third party, then it's not decentralized, right? If it's not a third party, then how do you know it's real? So I'm glad we're going to break this down, because I agree with you. Attestations is one of the biggest things that been having conversations about. And then the specific question of how do you verify that that attestation means anything? I love how passionate you are about this. So tell us, like, how do we actually, what are the opportunities and challenges um, of combining TEE-based attestations with Web3 primitives? And how can we know that they're real?
Yeah. So my favorite Web3 primitive is like zero knowledge. And I think with zero knowledge virtual machines, the things that already allow us to do, protocols such as proving and verifying, but in secrecy or privacy preserving applications that require no attestation, meaning that we don't necessarily need to believe in whether or not there's a root of trust. But the thing is that the root of trust is quite beneficial, because if I know where the keys are actually coming from, I can also attest to the application, and the application on that hardware, there are attestations that come into a package called a quote, and then we can measure that quote through a verification process. And so we've decentralized the verification process so that anyone can actually verify what's known as the root of trust. And if a zero knowledge virtual machine is running on that hardware as, say, that application, I can actually prove the inputs without actually having to reveal what the inputs are also. So that means I can extend the verification of a zero knowledge proof and have effectively anybody be able to verify. So it allows me to basically scale faster.
Right.
It's the same reasons why people are using zero knowledge inside of a TEE, so that they can have the privacy preserving nature of ZK, but then they want to be able to attest to the actual verification across many, many what's known as key management systems. And so that can actually be decentralized. And that's what we've done at Phala. By using the blockchain, I can actually generate quotes and verify it on chain, because that's what the chain does. The chain can actually, it can verify things fast, very quickly, actually.
Right. So
Mhm.
when you say we can verify and we can see the verification, um, I've noticed a lot of attestations are just a big page full of code and numbers and strings of letters, which that's great. I could go through that and verify that letter by letter that it matches something else. But is there a better way for people to understand whether that's real or not?
Um, That's a really good question. Yes. I think there's two ways. One, just like the Ethereum Foundation has been stouting now for, I think, like the last year, our job really in crypto and cryptography is to make the UI UX so much more clean. And we need to be able to provide like green check marks, but not just like green
Yeah.
check marks that go towards like a dirty HTML web page and you don't even know where it goes. Like we
Right.
really need like the block explorer of hardware, right? It's
Yes.
sort of think of it like that. And I've been saying this because it's not done yet, and we're
It's
working on it.
not.
And other people like Anamoka or am I, how do I pronounce their name? It's an
Animoco?
Andromeda, or
Oh,
yeah,
Andromeda. Yeah,
I
Andromeda.
believe there is other teams doing the same thing. Like, hey, how do we make the UI UX of the actual remote attestation as well as the local attestations more clear, so that a
Right.
decentralized application can provide the, green check marks that say, yep, this program does not have a
Yeah.
backdoor. Yes, this program does not have side channel attacks. Yes, this program is trusted by, you know, Uniswap or something. And yes, this quote actually of a price, for example, from a Chainlink did come from Chainlink, because we're going to
Right.
start mixing all of our infrastructure. And we've already been doing the trust me bro security model in crypto for like 5 years. So
Yes.
it's about time that, like, well, who's actually trusting who? Like,
Right.
that's the key, because we've done a lot of
Uh,
network events and there's a
and the
lot of
way,
sketchy crypto people. And I don't think a lot of people
right.
trust a whole lot of people. So this is sort of the point.
Right. Well, I mean, the way that trust is generated in blockchain, the idea, right? The central idea behind this is that we have a decentralized, like a DAO. There's multiple people voting. There's multiple people attesting to the solution to a blockchain transaction. It's all agreed. Once it's all agreed, everyone has a copy of it, and everybody, you know, promotes that one copy of the ledger. Whereas, the whole idea of a 51% attack is that if you can get more than half of the people on the network to agree on something different, then you could actually fork the network. So how do we get that? You mentioned that there'd be a block explorer that everybody agrees to. I guess the important thing is that we have some mechanism for consensus, some consensus-driven mechanism that this attestation is correct, this one is not.
Yes. This is where it's called zero trust verification layers. And I've been coining this now recently, and it's a layer of trust that is then decentralized, but then we know who to verify with, because not every verifier is actually honest. And so we need to be able to verify that there are certain trust custodians that are effectively within governance, and there should be slashing rules for people who actually lie about the data preservation, because we all still exist within the CIA triad. So if you're going to be doing something confidential, integral, and you're making data available, you need to do it right, correct, and trustworthy. And so some people require these hardware attestations, well, basically hardware upgrades, I like to say, is because if I have a validator and I'm part of the Ethereum network, I want to be able to basically eliminate MEV. So I want to move my Ethereum node into protected Ethereum. That's what I would like to really kind of paint this picture as, is like there's the hardware is available. It's open source. It's not necessarily like, oh, it's all coming from the RA, which is Intel, or AMD, or AWS, or all of these. They're offering, yes, the enclaves, they're called. The enclaves, which is just the processing unit of the computer, but it's up to you to actually make use of it.
So we're talking about how to make things more accessible by more people, by how to promote trust by representing things in a UI UX that's readable, not just machine readable, but human readable. What about TEEs? Is there a way for visual understanding to be improved of what's happening inside a TEE?
Yeah, I think it's pretty straightforward. Like with Phala, what we're doing is we're creating a UI dashboard so that developers are going to be able to kind of see like sort of like, like in Figma, where you can kind of see like screens. So imagine inside of those screens, you can kind of see all of the different quotes and attestations about the hardware, about the hash of the Docker image, cool. Because that's what DSTAC does. Like you deploy into Docker, you basically don't have to think about how to build a TEE. So you just deploy straight to the Docker, the KMS, the CVM, like all these different modular components that make up DSTAC. What DSTAC is designed to do is to actually provide these quotes, and these attestations basically can then be compartmentalized into this like very nice UI, and then you see all these little strings that kind of go all over the place. So it's very similar to if for anybody out there that's like learning smart contracts on Ethereum, there's a lot of tools that do this as well. It's sort of like what you see in Unreal Engine 5, even, where you get to build a game, but it's called blueprinting. So it's like blueprint the attestations, then in the UX, then what you're going to do for your users is then you're going to pull those quotes and then add the green check marks, right? It's like, this program is verified, right? So if it's like an aggregator and you don't really necessarily trust that this Solana application is actually running on a trusted validator where they're just basically peering on every single buy and sell order, how do you know that the program is actually honest? How do you know that the validator that's hosting these Rust programs, which are just basically binaries that live on accounts, how do you verify that they're doing what they're doing? So I've had a hard time trusting applications in Solana because of this. And because the memory is protected, I can't verify what that memory is doing. So the TEE will allow me to literally now actually trust what some of these applications are doing. And I think
So,
even
you know,
pump.fun can take advantage of this too,
I
or
feel,
something like that.
yeah, Pumped Up Fun could potentially as well. They certainly need something like that. I think you're very well versed in this idea because you recently shipped your first TEE app on Phala, right?
Yes.
So can you tell us, like, what did that process look like from idea to deployment? I'm assuming you integrated some of these ideas you're talking about, but what surprised you when you were creating this app?
Okay. So how fast it runs, because it runs faster than expected actually. So I was actually clocking in on my own personal computer at 120 FPS. And then as soon as I deployed the exact same application, it jumped to 250 FPS, and I was like, "What?" So I can make like 4K movies on a TEE, or I can do live streaming inside of a black box. And so it gave me this idea of doing like a podcast in a black box, literally. And so I as soon as I saw that, what was surprising about Phala was that I didn't need to set up the domain either. So it already gives me the program, but it's executable, so I can write any language, any programming language. So that was nice.
Sure.
And the deployment was very easy because the CLI allowed me to Dockerize my app, launch it immediately
Mhm.
to Phala, see it running, and then I can actually get an entire log that it's existing on this very specific computer hosted here, wherever in the United States. I can see that it's running at this rate. I can see that this is the
Right.
Docker hash of my Docker container. I can see everything. And it's up to
Well, let
me to
me,
kind of put in, I can use the CLI tools in my
right.
program, and I can
Mhm.
actually derive keys from the TEE as now as an API in my Python or JavaScript. So I can actually pull secrets like private keys, but in confidence in a JavaScript application. So like the
So
whole,
tell us, did you like the secret? Did you code all this by hand? Did you use any vibe coding?
oh, I vibe coded it for sure. Yeah, I used Cursor, and it was
Okay.
like it was like a night project basically. So I wanted to create like a way to log into Jupyter Notebook, but then only I wanted to be able to process the code on the browser. So it's like a private IDE, you can think of it as.
Mhm.
So I wanted to have a password. I wanted it to say like, any of the data that I input has to be coming from the administrator. So it's almost like a private console. And then as soon as I started running it, it was running Python code within a Python code application, but on a TEE. And that's when I was like, okay, I'm surprised. It's fast,
Yeah.
and it's protected, so only certain people actually get to access this. I can also prove that I'm the only person who's allowed to access it, because I can also give the application my public keys, so I can
Mhm.
sign everything. So if I'm going to send data from the Jupyter Notebook, I can send it with a private key that's signed in the enclave, but then always
Mhm.
ensure that I'm signing it with my public key. So you never give private keys to anything. But in this case, you can, because you can
Right.
trust
Cool.
that it's not going to steal it, because it's actually the root of trust is coming from a decentralized KMS. So
Very
as I
cool.
began to learn about this, I was like, oh my God, I can make light clients with this thing. Oh my God,
Mm.
I can make oracles with this thing. Oh my God, I can do
So,
verifiable
so
randomness with this thing.
can people test out your app? Is it
Uh,
public?
well, I do have a link actually. So it's funny that you
Okay.
asked that,
We'll
because
share the link. We'll share the link when we edit.
for
Um,
sure.
yeah, people would probably like to see what you built, and maybe by the time we publish, you'll have a couple other apps out by then as well.
Yeah.
Um, So let me just ask you, let's move on to just talking about ZK and TEE. How do you see these two technologies complement each other, and the different use cases that are good for each one or both?
So, okay, so we were just talking about this the other day, but there are some entities out there that have done so much work in zero knowledge virtual machine work. And so we recently at Phala, we were able to run the succinct prover inside of the TEE, and it was much faster than running it locally. And
Right.
also, if we were going to be, say, building an application that's in the browser, then I would want to be able to attest to the zero knowledge proof that was actually being ran in the browser without actually having to wait for the browser to actually run the prover, because the
Mm.
browser doesn't actually have sufficient CPU and processing in order to run a zero knowledge virtual machine. So then some
Yeah.
people are getting really creative and they're saying, why don't we just like allow for the browser to attest to the TEE and then have it
Right.
verify that the proof was generated in the browser,
Mhm.
but through a remote attestation through remote view. And
Right.
so
So
that is very
then you have the
cool.
compute happening where we can handle the compute, but you also have the attestation right up front with the browser with the user.
Yeah, like I input the data at this exact time, at this exact
Yeah.
nonce, at this exact signature, and I'm this exact public key. So return the data back to me and then hash it when I go in. And then if I get the data and it's not the same quote, which is the attestation, okay, then I know that the root of trust lied or the registers that hashed the data to create the quote also lied. So that means it's not the right verifier. So that means if I chose the verifier of Bank of America and I wanted them to generate my zero knowledge proof, and then they said, okay, well, we trust Chase because they're our homies. What? Like, no, I wanted Bank of America to make me
Right.
this quote, give me the proof, and then don't reveal it to yourself because it's in zero knowledge. So I don't know
Yeah.
what they're doing. Yeah.
Yeah. Have there been any moments, so when you're talking confidential apps end to end, I guess, have there been any moments of aha or difficult roadblocks that you encountered that you weren't expecting?
Um y- so it's a steep learning curve for sure. Like if you're if this is the first time you've ever heard about TEEs, like when I was getting into it, I was setting up an SGX for the first time and it took me 3 months. So like from scratch. And this was like a few years ago. So I was before like AI and all these things and having like awesome access to a bunch of tools like DSTAC, right? DSTAC makes it now like one click wonder. That was the hard part. So
Right.
that was the aha moment for me was is that there was actually builders out here trying to make the hardware process not only decentralized but also easier to do. And so I believe we need to keep doing this because the
Makes
more
sense.
ease of use that we do for ourselves in the sort of the infrastructure world, we're going to see much more faster adoption. um,
Right. Right. Because if it's a big hurdle just to get the infrastructure up and running, it kind of stops you in your tracks before you get going. I bet you have, I'm just going to ask you this question. If not, we can skip it. But do you have like a d dream project in your head that you're moving towards and that kind of showcases the synergy of TEE and attestations, decentralization, and ZK? Do you have something like this was a sketch, if you will, and now you're going to move towards some bigger project?
Me personally, yes. I do have my own project that I've been working on now for about 3 years. As far as Phala, though, is concerned, yes, we are building out the UI UX of the remote attestation and verification dashboard so that any developer is going to be able to effectively be able to use it like an API. So if you want to
Incredible.
verify the root of trust, just use this
Yeah,
API and it's going to be coming
nice.
into these like very specific registers. You want to verify a specific register? Cool. You could do that too.
So needed.
Um, short answer is yes. We do have plans for the future for that specifically. For myself, in terms of zero knowledge, yes. Also, zero knowledge passwords. I think like any system that is going to run on a TEE is going to require zero knowledge to some degree. I'm just a very firm believer in privacy preserving applications, and so so I did build a system that is going to allow us to basically have protected entry. That means you can't actually get the password when actually inputting the password. And so we use new forms of cryptography called lattice-based cryptography. And so lattices could give us effectively this ability to actually be able to provide information to a grid-like architect. And so this can actually prove statements about proofs it's themselves. And so zero knowledge is going to evolve actually over time. Zero
Beautiful.
knowledge is not actually as private as we think it is. It can be more private, meaning
Right.
that at the witness, there's something called a witness phase basically. So like when the data is actually viewable to the host. So that's the thing. Like the host can't actually be trusted with running a zero knowledge prover because to some degree, the host can actually verify the actual information itself, including master keys, nonces, salts, and so we don't actually know or have a standard in zero knowledge. So I believe that if you're going to be like trusted to run a zero knowledge proof, unless you're running something that's actually standard, if you're creating a non-standard zero knowledge virtual machine or a non-standard zero knowledge proof, which has already been found to be not secure, not actually beneficial for most people because there is no standard in general. I think that's where you would have to use TEE to at least attest to some of the security guarantees before you actually do your audit. So yeah, and that's where it
So
starts with.
from what you've said, I'm going to guess that adoption, right? Let's talk about adoption. What are the missing pieces? It sounds like you're saying the ability to do remote attestation, to call an API that will do this for you, the ability to do this in a more simplified way with tools that are better built out is a big piece to wider adoption of TEE infrastructure. Is there anything else that you think is needed or missing for us to be able to move forward into a world where everyone uses TEs by default?
So why should everyone use TEEs by default, right? And it's because A, it's accessible. B, it's possible that new hardware manufacturers actually end up creating their own processing units where they can offer the actual sealed agreements in a processor. So these are open source, and you can install it onto any common everyday processor, and you can trust that the certificate authorities are not actually going against you necessarily. There's a lot of regulations in and around the actual certificate authorities. There could be a day where we decentralize even the HSMs that do the certificate authorizations for the world, like through Certbot and OpenSSL, and like everyone knows that the internet is decentralized, but it requires certs, and
Yeah.
that's all centralized. So like,
Yeah.
what are you going to say? Is the internet not decentralized just because there has to be some sort of like underlining security protocol to it? Like,
Well,
it's
maybe.
still using
Yeah.
TEEs. That's the thing.
Yeah.
Like, it's
Right.
maybe the data is centralized, but not the way that it networks itself. That's why
Yeah.
the FBI can't like go and track down like exactly who's laundering systems in Tornado
Right.
Cache, because like,
Mhm.
yeah, it's sufficiently decentralized just the way it routes, because Tor and because onion routing works. Like, these things are available. And so through privacy preserving systems like RSA, just like the common things like TLS that give us the encrypted data sort of pipelines between how systems communicate with one another, the TEE is there so that you can process the data in the same confidential way without actually extending the actual compute to a prover that is actually a malicious host. Because in
That's
crypto, you're proving
mhm.
that a smart contract needs to be ran, but then if something is actually viewing that smart contract and then it sees that your public address is affecting this contract and it starts running some untrusted process, well then like, how do I know that I'm being targeted or attacked or anything? And so I want to be starting to use applications that I feel like I have more control in, because in the future of AI, it's not going to be safe because we're not even thinking about safety. It's not even regulated anymore. So if we're gonna actually see a secure and safe AGI future, my belief is that, as well as like what we're saying at Phala too, is that everything has to be confidential to some degree, because
Mhm.
if people start giving away all of their data, they're gonna feel like they're having less and less control of their everyday lives when everything becomes autonomous and automated, and you feel like your digital twin identities or the deep fakes end up actually attacking you. So if an
Mhm.
application that you're using actually peers on your data and starts using it against you, you're going to want to know if whether or not an MCP, like other agents, are watching you. Just like how a car,
Yeah.
like a Tesla, actually is recording and monitoring all the streets. And so, yeah, it knows how to drive safe because it's collecting all the data. And it's
Yeah.
not
Right.
doing so in a way where it's like verifying that it collected this data. So, in the
Mhm.
future of real confidential AI, it truly means just don't trust, verify. And you
Yeah.
have to, because this is still the same thing Bitcoin is going to do, the same thing I believe Ethereum is going to do, and the same thing that we're going to try to do. But we need to have the same hardware to make this happen.
Right. Well, you answered my last question, which was, should we do this? And I think what you're saying is that should everybody adopt TEs is the question, or decentralized confidential compute. And I think what you're saying is that if you don't, you leave gaps, you leave holes where data can spill out. And unless everything is secured, there's no security unless everything's secured.
Well, there's still a potential for leakage, right? Like let's dispel the smurf in the room that says like, oh, it's not perfectly secure and it's unhackable, right? It is hackable. It's called a physical attack. So unless you
Of
actually have
course.
physical access to my actual hardware, then yes, you can do some crazy methods like oscilloscope or stenography or like measuring the actual timeouts. And like that's why we suggest that any code that you deploy to the TEE, just make sure that it's constant time because then you can avoid the side channel attack. And then,
Right.
oh, like if you're going to have like a public key or a private key, don't put it inside of the code because people can still see the public image of the code.
Right.
So make sure that you encrypt it using the decentralized root of trust from the TEE and then sign it with another public key. And you can effectively still sign it in confidence, knowing that the memory doesn't actually store anything unless you're using the TEE to store something. And if you are, well, then yes, you can trust people like Phala who don't have any incentive to go and hack their own computers because that's not what they do. And if you don't trust the actual physical computer and the host of that computer to not actually tamper with the actual device itself, that's the next thing. It's like
Right.
literal physical
Right.
hardware security, like big wrappers and titanium boxes over this thing so you can't open it. So
So,
yeah.
I mean, this is super interesting. It's like, there are best practices that you can do to minimize even the impact of a physical attack, it sounds like. And I
Yes.
don't think I've read that anywhere else. So I'm going to look into that some more. It's really interesting. But I just wanted to say that clearly, Dylan, you've landed in the right place. It's clear that you're passionate about these topics and that you're able to explore them through this role at Phala. And I'm so happy to hear all of these ideas coming together, and I've learned so much. So thank you so much for being with us today. We would love to have you back to dive into some of these topics in sometime in the future.
Yes. Thank you so much for having me and letting me just spill the tea.
Yes. Thanks.
Absolutely. Thank you.